start off with physics 2 again, and basically we're going to talking about an object that's moving at a certain velocity, and the object is also going to have a mass m kilogram, as you can see from this diagram here. Now we can also see from here that a certain time later, shown by delta t, okay, delta t here, we're going to say that the velocity of the object is going to change, and we're going to show this by the final velocity. Now what we can do now is we can look at the change in the velocity, change in the momentum. So momentum itself is actually going to be equal to momentum. The formula for momentum is actually equal to mass times that by velocity. Now, because obviously the object is experiencing a change in the velocity, we can now say there's a change in momentum. Change in momentum in a given time, and we can write this as mv minus mu, which is actually the change in momentum. If you divide that by time, we're going to get this expression here. Now when we obviously continue with this expression here, we're going to say now that we're going to factorize this top equation here by taking out the m and leaving the v minus the u inside the brackets. That's all going to be divided by t. Now we can see now by looking at this that the change in the momentum over time is going to be equal to this expression here. Now what we can say is that by introducing now acceleration, we can actually say that v minus u over t is actually equal to the acceleration. Now in order for an object to actually experience a change in velocity, the object needs to experience a force acting on the object. So what we can say now is that the force is actually equal to mass times acceleration, and this is basically one way we can actually introduce Newton's second law of motion, which is going to be shown like this here right now. So this is Newton's second law, where we can say that the change in the momentum, or the rate of change in momentum, i.e. the change in momentum divided by time taken, is directly proportional to the force acting on the object, and also in that same particular direction. So again, I'll say it's a rate of change in momentum. The rate means divided by time, so how quickly momentum is changing, as you can see from the top diagram over here, is going to be directly proportional to the force acting on the object. So if the momentum changes, it increases, therefore the force also increases as well.